My dear students, today in this lecture I will introduce some of the basics of mobile communication standards such as GSM and CDMA technology. Also, I will explain some of the key points related to 2G and 3G wireless communication systems. So, this portion is in the syllabus of Polytechnic lecture exam for computer science, and each portion is important and it will determine your career. Let's go through the basics of GSM technology. GSM is a standard developed by the European Telecommunication Standard Institute, that is ETSI, to describe the protocols for second generation digital cellular networks used by mobile devices. So, the first main key point to understand from GSM is it is developed by the Institute, European Telecommunication Standard Institute, that is ETSI. That is GSM stands for Grouped Special Mobile, and it was first name. Later it is named as a global system for mobile communication. That is, we are using a global system for mobile communication for GSM. So it defines the set of protocols or set of standards for the communication between the wireless cellular devices such as mobile phones and tablets. Next, we will see the different multiple access techniques which is used in GSM systems. It is also asked in different competitive exams, the multiple access systems used in GSM technology. So, GSM system uses TDMA in combination with FDMA. That is, it can use either time division multiple access or frequency division multiple access. That is, it can divide either along the bandwidth or along the entire time duration. In the frequency division multiple access, bandwidth is divided into different orthogonal frequency bands, and each frequency bands is given to different users for sharing the communication resource for the entire time duration. That is, in the frequency division multiple access system, the communication resource is sharing along the mobile devices for the entire time duration, but with different orthogonal frequency bands. That is, let's see this figure. The x-axis it's showing the frequency. That is, in the frequency axis or in the bandwidth, it is divided into two bands, that is for channel 1 and channel 2, and this different frequency bands is given to two users, and the frequency bands are orthogonal to each other, therefore there won't be any multiple access interference. The two users can transmit the data for the entire time duration. That is, time is same for different users, but frequency band is different. Next, we will see what is time division multiple access. It is also a multiple access scheme which is used in shared medium networks. That is, here the different users share the same frequency channel or same communication bandwidth by dividing the signal into different orthogonal time slots. That is, each user can use the entire frequency or entire bandwidth, but for different time slot or different time durations. So here also the multiple access interference can be avoided by allocating the communication resource for different time slots, but for the entire bandwidth. It was first used in satellite communication systems, and later it is used in 2G cellular systems such as GSM technology. The problem with using TDMA is it requires accurate synchronization between the transmitter and the receiver. So in the multi-carrier systems, it is the main multiple access systems. Let's see how TDMA works. Let's see the figure. Here the x-axis showing frequency, and the time axis it is divided into different slots, that is slot 1 to slot 4, and each slot is given to different uses for accessing the system for entire frequency spectrum. That is, frequency allocated to different uses in TDMA system is same, but the time slots are different for different uses. So in this way we can avoid the multiple access interference. Next, we'll see the concept of frequency reuse. In the GSM technology, there is a totally 124 subcarriers. That is, a total number of carriers are 124, and each carriers can be divided into 8 time slot, out of which 7 can be used for data traffic. Therefore, we can make 7 into 124, that is 868 calls at a time. But this is not enough for the large communication scenarios or heavy traffic areas. So the same frequency have to be reused for the different coverage areas, and this concept is known as frequency reuse. That is, in the frequency reuse concept, frequency is allocated to the different uses. In the cellular technology, each cellular base station is allocated a group of radio channels or frequency subbands which is used within a small geographical area, and it is known as cell. The shape of a cell is hexagonal. So in the frequency reuse concepts, the same frequency can be used by different cells which is not adjacent to each other. So in this way we can reuse the frequency for the different cells which is not geographically adjacent to each other. So by using this concept, we can increase the spectral efficiency of the communication system, and also we can increase the signal quality. Let's see this figure. Here the same color showing the same frequency is used by different cells, but it is not adjacent to each other. So there won't be any interference between different cells. So we can use the same frequency by allocating the same frequency for the non-adjacent cells. Next, we will see the basics of CDMA technology. CDMA is a sort of multiplexing that facilitates various signals to occupy a single transmission channel, and it is very different from the time division multiple access and the frequency division multiple access. In the CDMA technology, each user can use the entire spectrum for the entire duration, but with different orthogonal codes. That codes are known as PN sequence or spreading codes or Walsh codes. Different orthogonal codes can be allocated to different users for accessing the communication resource for the entire spectrum and for the entire duration. CDMA technology uses a code which is known as spreading code, and these codes are orthogonal to each other, and it is possible to select a signal with a given code in the presence of many other signals with different orthogonal codes. That is, each users can be allocated with the different orthogonal codes, and during the transmission each user transmits its information by spreading with unique code, and that is, each users have its own unique code and it is orthogonal to other codes for other uses. That is, uses are separated by code, not by time slot or frequency slot. For spreading the code, we can use the techniques either direct sequence spread spectrum, that is DSS, or frequency hopped spread spectrum. Next, we'll see the features of CDMA technology and how it's work. CDMA is a spread spectrum techniques which allows many users to occupy the same time and frequency allocation, but with different orthogonal codes. X-axis showing the frequency and the y-axis showing different uses. Here the frequency is same for all the uses, but different uses are given by the different codes, that is code 1, code 2, code 3 and code 4, and these codes are known as random codes or pseudo-random codes. The use of CDMA offers several advantages. So it is used in 3G cellular telecommunication systems. Recently, CDMA has merged with the GSM technology to give a high-speed 4G or LTE internet services. Another important points to remember from the CDMA system is CDMA use soft handoff, and it is also asked in different competitive exams. The handoff used in CDMA systems were soft handoff. Next, we will discuss the advantages of CDMA technology. Because of using different orthogonal codes for different uses, the security of the CDMA communication systems are very high. In the CDMA technology, we are giving different codes for different uses for the same frequency spectrum and for the entire time duration. So different simultaneous conversation or different calls can be made at a time. The efficiency of the CDMA technology is very high compared to the TDMA and FDMA technology. And other advantages are low power requirement for the cell to cell communication. So CDMA is a power limited system, but TDMA is a band limited system. That is a key advantage of CDMA technology. And another advantage of CDMA technology is extended the communication ranges. That is the communication range or the maximum distance from the communication source towards the users can be increased to a very high value. Next, we will see the advantages of GSM technology. We know that GSM is a cellular technology used for transmitting mobile voice and data services. The first advantage of GSM technology where the signal deterioration is very less inside buildings. That is, if the path loss for the communication is less, then the signal attenuation will be very less. The second advantage is the call duration or talk time is very high in GSM phones because of the pulse nature of the transmitted signal. The next advantage is the availability of SIM helps the users to switch from one network to another network. We know that the memory device in GSM phones is the subscriber identity module or SIM card. Therefore, it allows the users to switch from one network to another. The another advantage of GSM is it will cover all part of the world, so the roaming is not a problem. There is no roaming charges on international calls for GSM phones. That is, the connectivity is worldwide and extensive coverage. That is the main advantages of GSM technology compared to other mobile technologies. And next, we will see the classification of CDMA systems. Mainly, the CDMA systems are classified into two, that is CDMA 1 and CDMA 2000. CDMA 1 again classified into IS standards, that is IS 95 and IS 95B and JSTD 008, and this comes under narrowband frequency range. In the wideband frequency range, the CDMA 2000 is divided along the very high frequency, that is, it comes under ultra wideband frequency range. Next, the some of the key points should remember from CDMA systems are about the types of code used in code division multiple access. That is, we know in the CDMA systems the users are allocated by using different orthogonal codes. So you should familiar with the types of code which is used in CDMA systems. The first type is Walsh code. These are the orthogonal codes. That is, the two different codes are orthogonal to each other, and each code is allocated to different uses. And it is based on the IS 95A or IS 95B standard. The next classification comes under Walsh code is CDMA 2128 Walsh code. That is, CDMA 2000 uses 128-bit Walsh code, and narrowband IS 95A and IS 95B uses 64-bit Walsh code. The another type of code is PN code. It is also known as pseudo random codes, and it is of the length 16-bit. The different PN sequence can be used to identify the base station and hence the cell or mobile uses. The next classification is long PN code. That is, in short PN code, the number of bit is 16 bit. In long PN code, the code word length is 42 bit. And it is used to identify the mobile station on reverse link. So please understand the different types and the communication standard for different types of codes. The other key factors should remember from CDMA systems are diversity. The CDMA systems can use either time diversity or frequency diversity or space diversity. The difference between GSM and CDMA technology can be summarized as: first, based on the type of storage used. In the GSM technology, the storage device used were SIM card. That is, SIM card is used to store the user's information. In the same side, for CDMA technology, the memory device were internal memory. So in the CDMA technology, there is no need for SIM card. Next, the network service. The network service for GSM technologies depends on the user's SIM card. But for the CDMA technology, it depends on the user's device, because of the internal memory will act as a storage device for CDMA technology. Next, for international roaming, there is no roaming charge for GSM technology. That is, international roaming is easier in GSM technology, but it is more difficult for CDMA technology. Next, the frequency bands. GSM technology support different frequency bands. That is, it can support frequency range from 850 and 1900 MHz. But the CDMA technology support only single frequency. That is, all the entities will use the same frequency, and it is in 850 MHz. There is a main key point in the frequency band which belongs to CDMA technologies. It is a single frequency, and the frequency support by CDMA technology is 850 MHz. Next, the data transfer technique which is used in GSM technology, where GPRS is a general packet radio service, or 3G or 4G or long-term evolution or LTE service. The CDMA technology, it can support the data transfer EVDO. That is, EVDO is evolution data optimized. It comes under CDMA 2000 or IS 2000 standard, and it can also support 3G, 4G and LTE, same like GSM technology. And this shows the market share by the two technologies such as GSM and CDMA. Around 76% of the total peoples are using GSM technology, but only 24% peoples are using CDMA technology. That is, CDMA technology is very complex, and so many problems with the roaming and the frequency reuse factor. The peoples are preferring GSM technology. The frequency reuse factor for the GSM technology is 3. That you should remember this point. The frequency reuse factor for the GSM technique is 3, and it is used in 2G cellular networks, and it can use both the multiple access systems such as TDMA and FDMA. That is, it can use either time division multiple access or frequency division multiple access systems. And the handoff used in GSM is soft handoff. These points you should remember before going to the exam.